Good morning, sir.
Hello, good morning.
Yes, sir.
So, how are you doing?
Mm, Fine, sir.
Fine. Is this, are you on vacation or holidays? This is
Sir,
something like festival season?
yes, tomorrow is a holiday, sir.
Okay, okay.
Mm. So, will you take class tomorrow, sir?
No, I don't take you on holidays like for you.
Okay, sir.
You may have plans of it, right?
Thank you, sir.
Yeah. Um, Monday, Tuesday is okay? Or Tuesday is
Yes,
also holiday? I didn't check
no,
the
sir.
calendar.
The Tuesday, I think fine, sir. Tuesday is not holiday.
Okay, okay. Tuesday I will.
Yes, sir.
Okay, let us begin. Uh, I think um, we are discussing the memory mapping, these things, and I was asking, addressing some questions. Um, yeah, the mapping we are trying to associate. Uh, this one, yeah, we have seen some surprises like kind of like taken x1 y1 x2 y2 hetero association x3 y3, and we find out something called w, and we successfully retrieved y1 y2 y3 through the w. That's what we have checked it out so far. That is wx. This is the matrix, is the thing which is doing all the memory association. Now the question I asked is like okay, the natural question, when it can go wrong, uh, at what is the condition, or what kind of association, or what kind of um, uh, input conditions, like these things, they may not produce the memory association, or what w cannot give that, and what we are expecting. Or we have seen that these are all like, even they are earlier in the first beginning example we have taken orthogonal. I think these are these inputs are not orthogonal. Even they are not orthogonal, they are working out due to the reason, um, I the eigens concept. Actually, there are basins. What basins I am talking? Basins of attraction. So these decision regions or basins actually uh, uh, talking very loud. So I think you can able to address this question. You don't neglect this one. I will give you enough inputs to address this question. Um, and now to address this question, you must know the linear algebra very strongly to identify the basins of attraction. Now to understand what does these basins of attraction, and the what shape they have, they usually in the shape of cones or polyhedral, I could say, in the eigenspace. Maybe I will give little more details about the geometry. Okay, I will go ahead with the same example, and I will continue with this, how the basins of attraction for this one, so that you will understand. Okay. Let me write out the two or three. Uh, how many eigenvectors you have now here in this? Or the decision regions you have, minus what are the things? Yeah, fine. And these two, let me write them up. This is the space from R3, some three-dimensional to two-dimensional, so that we need the W in vectors of 3, and looking for the vectors of two components, what I mean. So we are looking the basins of attraction in the domain, not in the codomain. We will always see the eigenvalues in this 3 space, how they are looking at, we will see. Okay, I'm just going this one. I may go front and back for a couple of minutes until I connect completely with the problem. uh, okay, so let me write out the matrix W. uh, what is that W?
Minus 1, 3, 1.
Yeah, please tell me. uh,
Minus
minus 1
3, 1. Row I think.
3 1. Yeah,
Minus 1, minus 1.
minus 1 minus 1
1.
1. Okay, so this is the matrix we have in front of us. Let me take um, this vector as something W1, this vector as something W2. So I will take them. W1 is a column, minus 1 3 1, and W2 minus 1 minus 1 1. So now if I have and these two vectors which are W, which are sitting inside the W, what they are saying about, we'll see. uh, if I write up the geometry of this one, let's see, this is the matrix, it is doing all the things. Now I just wanted to see how they are looking at in the geometry. uh, Let me take a simple geometry. How uh, this one. So these are all the coordinates x1, x2, x3. So W1, like you can think of W1 transpose x bar, equal to 0. The corresponding to first one, and the second one corresponding to W2 transpose x bar equal to 0. These are the two planes. If you draw out the two planes into the space, into the R3 space, or then uh, how do you like these two spaces forms, like I cannot perfectly draw a plane here. Let's see, let me try it out. You can imagine much better than the picture. There's something called one plane, and of course this plane is passing through origin, because of there is no constant here. All the W1 W2 W three coordinates in this, they are having the w1 x1 plus w2 x2 plus w3 x3 equal to 0. You can say if the coordinates are w1 w2 w3. So I don't want to go too much index notation. So just think of like there are two planes in 3D. There are two planes in 3D. One is the first plane corresponding to W1 bar, and next one, and think of like this is not just starting at that one, and think of like a plane, just think of like a room having with a basement x1 x2, uh, and there is a height wall x3, and you can see there are planar in the here this side, and there is a wall this side, and there is another wall this side. And you can if you have two sheets with you, a long two sheets, and you are slant trying to stand those two sheets through this point, and they are other side of that as well. You don't think of this is the limit of the boundaries. There is a negative aspect of behind the axis. There is parallel to this one, there is a negative, there is a parallel to this one, there is a negative axis, and there is a parallel to this one, and negative, that is bottom, that is the behind the wall, behind the walls and behind the floor, and push a, a sheet, a kind of like this one, into behind the walls. And there are two walls, there are two such sheets. This is a one sheet, and this is completely one sheet, we can say. I don't write up behind things because it fills the diagram completely. And think of like another sheet is somewhere, like this way you can think of. There are two planes. Okay. Okay, there are two planes. Now, fundamental, you know the planes and all. I don't need to go about the mathematics behind the planes, what the planes represent and all. Um, there are two planes, plane 1 and plane 2. Let me write up them as plane 1 as pi 1. You can think of like uh, W1 transpose X, and plane pi 2 as W2 transpose X. Okay. Yeah, I don't elaborate the equations. You know the equations, the plane equations. That is in x1, x2, x3 with the w1 dot. That's a dot product. It represents a plane passing through the horizon. Now, what can we understand from this? From the w, we are trying to understand how they are looking at it. Now, if you look at this one very clearly, I have four choices with the two planes with you. Two planes sitting there, and I have four choices. What are the four choices? The four choices, four regions or four spaces it is dividing. How it is dividing? Um, Let me take this one. I will go with the W1 transpose X is greater than 0, and W2 transpose X less than 0. This is the one region. You know the greater than, less than, right?
Yes, sir. Yes, sir.
Like in 2D, it's simple. Like if you have the line equation like this, uh, in 2D, I'm just explaining the same thing goes for the this one. You have a positive side, that is maybe you can say greater than 0, and the other side is less than 0. On the line, it is equal to 0. So this is a dividing entire space into two parts, right? Two parts. And now if you have two lines, if you have two lines in 2D, uh, this one, let's say, okay, for this one, then again it is also dividing space into two parts. One is positive side, other one is negative side. Each one have two half planes. Entire plane is entire, what is called the dealing R2 or R3 is divided into two parts by that line. Okay, that's what intuition here. The same thing goes here. Now, by doing at them, what are the possible combinations or what possible pieces we can see out of all these two planar divisions? That is, one is positive, one is negative, and the other one is W1 transpose X less than 0, and W2 transpose X greater than 0, and the third one, W1 transpose X greater than 0, W2 transpose X greater than 0. For W1 transpose X less than 0, W2 transpose X less than 0. There are four regions of the four pieces of the plane space. Like these two planes dividing entire R3 into Each plane divide entire R3 into two half spaces. One side you can take it as H plus, other side is you can take it as H minus half space. For the both the same, like you can think of four such regions. Now, each region is a kind of like what would be shape of this one? Like if you take any region, can you imagine what kind of shape it look like? The region, suppose if you take in the R3, sorry R2, if I take some this region, this one and this one, and it is something like uh, it is something like this part, this one part, right? And then maybe this one is another part. It is an R2 replica, but we are dealing in R3. You can compare the space is divided into four parts. It is also divided into this one. Now, can you imagine what here you can see something like a polyhedral or kind of thing, a conical, and of course, this is
Sir,
the origin. Yeah,
conical types in this case, sir.
sorry.
Conical, sir. Cone with
Yeah, yeah, it looks like a cone. Yeah, of course, it looks like a cone. I don't know. Explicitly.
if
Uh,
there is symmetry, then we can say cone. Otherwise, we can't
of
say
course.
cone.
Yeah, cone,
Uh,
maybe stretched cone or kind of thing like this, or
yes, sir.
and also, yeah, a kind of like this is the space, so that it is not a hollow cone. It is a solid. Understand, it is not a kind of like only the surface, it is also filling with the surface, because the greater than and less than, they are taking every point into the consideration. And when you take out when you cut out two spaces in between gap, this is there is no gap at all. One is positive for one thing, another negative for another thing, then it brings every space into the thing. It is actually looks like a like cone. Of course, the cone shape only, cone. But I don't call it as exactly the cone, because I don't see any curvature or something. As to mention, it is cutting the space into the four parts. I call it as a polyhedral cone. Um because the cone is formed by the sides. Like if I suppose, the cone actually looks like something, this one, this one, yeah. And this is the one thing, this is the one. In this case we have only two, such that one is giving this one, another one is giving this one. But if you have multiple w1, w2, w3 and multiple things, then it may give another side as well. We have only two combinations, it may have multiple combinations of that. So that in such case, your cone may get a kind of like this. It is a kind of, it comes like this, if there are
Yes,
four
sir.
such, three such, you understand.
Yes, sir.
And
There is no curvature, sir.
no curvature.
Yes, sir.
You don't see curvature kind of thing, the cutting, unless you cut this one with another half plane. But there is here we are not cutting the cone, it is infinite. Yeah. We are not cut, this is a infinite bound. Like this one, there is no end for it, right? In the 2D, there is no end for it, it is goes forever. We are not cutting like a curve shape and all. So okay, you can think of relate to a cone, but the shape is not much important. But the visualization, how many parts it is, we don't use the like one thing we can get it about the space, shape. That shape is, if you know the convex, and the shape is a convex shape. Do you agree? I climbing convex shapes. All the above four are convex shapes. Convex shapes means, what is the definition of convex?
Convex functions are like if we take any points
Hmm.
inside the space, Then
Mm.
the line segment also passes through that point, sir.
Yeah. So now
Uh,
if you take any of this segment, any 2 points you choose, and always it is staying inside, it don't go outside the line segment for these four spaces. So that is the nature of polyhedral or polyhedral cone. If you take any cone as well, it will pass through it. It don't go. It try uh, the connection do not take outside of the space, outside of that part. So each shape is a convex shape. So this convexity nature is actually bringing a beautiful thing. Now you have to tell me, out of all these four, uh, which region contains, according to our W matrix, or according to our example what we are dealing with one, we have something like x1. I don't remember actually. I need to go the notation for association. Okay, we have scripted up. Okay. Hmm. X1 is mapped to y1, and what else we have? X2 is mapped to y2, and x3 we have mapped to uh, y3. Only three or more? I guess three. Yeah, three only. X3 to y3. Three matrices we have summed up. Yeah. Now tell me. Um, Now the question is the basin of y1. Basin of y1. What does basin of y1 means? What does basin of y1? I told you already earlier. What does basin of y1? What is y1? Let me write up y1 as well. What is y1? Can you tell me? I don't go up.
1 minus 1.
Yeah, okay. 1 minus 1. Okay. What is basin of y1? Basin of y1 is
W matrix, sir.
basin of y1 is the vector, not w matrix. W matrix is fixed. Basin of y1 is the vector, the which is sending to y1 is sitting in which region it is sitting. That is what, like, basin attraction means. What, like a simple basin attraction, we have already seen that. Like if you have something to target, a target function, target point, a converging point are x equal to a, and now if you find through some dynamical system or some iteration procedure, and you find some region where all the initials, it is a process to converge this one, and through a function f from a iteration procedure or something, and what initial x you have to choose such that it is always travel towards x equal to a and goes to the a. That is the thing. Now the region, what access or what initial or what points will land you and take you properly at x equal to a are the basins. The collection of all points, all initial guesses are all the points which can travel towards to the converging point under the mapping f, whatever we defined. The region is called basin. That's in a simple. We have seen a simple example. We have, I think I have given a last time, the convex optimization, writing up for the basins of attraction for some Newton raption or something. Finding it out the regions, like I think three regions, I guess. The set of all points which are mapping to uh, converging to the root one, and mappings which are set of all points which are converging to omega, and set of all points which are converging to omega square, right? If I am remembering correctly. So
Okay.
the if you draw this one with the different colors, the regions, those regions are the basins of attraction. Okay, now the same thing. What is the basin of W? Basin of W is this one. Basin of W2 is this set, the color which you have plotted. Basin of 1, that means the points which take you and land you on 1 is the basin. The same way, now what is the basin of Y1? That means not just the X1, what are all points we can take you into the Y1. Now tell me, the question is, basins, you can see there are four regions you can see here. Out of these four regions, uh, we need to figure it out which one is for which one. What is the basin of this one? What is the basin of this one? What is the basin of this one? Basin means taking and land you on the Y1. Tell me, you have W in front of you, and you have XS in front of you, X1, X2, X3. You have Y1, Y2, Y3 in front of you, and you have four regions in front of you. All the things are in front of you. Now you need to connect and identify the convex shape. Which convex shape is belongs to which association? There are four regions and three associations. Uh, Figure it out uh, the space, the associated. Can you try? Tell me. Do it, please do it. So find out basins of Y1, basin of Y1, basin of Y2, basin of Y3.
Sir, basin of Y1 is, sir,
Hmm.
W1 X transpose greater than 0 and W2 transpose X in less than 0, sir.
The first
Uh,
one.
yes, sir, first one.
This one, first one. Okay.
Sir, I
This.
just could try to calculate, sir, like
Hmm.
1 comma minus 1 is belonging to like
Yeah.
something in
Yeah. Yes.
fourth coordinate, sir.
I don't think of coordinate system here, like because the we don't have coordinates for that we can't number it even in the 3D. There may be eight species of it. Yeah.
Uh, One way, sir, like W1 X, like first Y first part is greater than 0, second part is less than 0.
Hmm.
That W
Yeah.
and X greater than 0,
Okay.
W.
Yeah. You are thinking like the entire space is divided into four quadrants.
Yes.
Mm, yeah, four quadrants, but I don't. If we can say quadrant term, I don't know. But here, because the four parts are may not be equal parts, four parts you can say four half spaces, four shapes. Yeah, yeah. Tell me the next one. Basin of Y2, basin of Y1. As you said, this one would be W1 X greater than 0, and W2 transpose X less than 0. Yeah. Now basin of 2, basin of Y2. I don't know what is Y2.
Of Y2 is W1 X, W1 transpose X
Hmm.
less than 0
Okay.
and W2 transpose X greater than 0.
Greater than 0. Okay. What is the Y2 vector? I will write up here.
Y2 is, sir, minus 1, 1 column.
Minus
Yes, sir. And
basin of Y3. Maybe Y3, I guess 1 1. Hmm.
Yes, sir. Y3 is 1 1, then W1 equal to 1 2. So W1 transpose X greater than 0.
Mm.
Okay. W2 transpose X greater than 0.
Okay. So
This
you
is
got three inputs and three regions forms this one. So this region, I can say that it contains this region contains x1, and this contains uh, x2. This region contains x2. This region contains x3. Right. Another one more region. It is the fourth region. It is not mapping anything. A region. It is not at all used, or not, there is no use of that. Okay. This one, these attractions are basins of attraction. Actually,
so these
uh,
are correct or wrong, sir?
huh?
So these are the correct or wrong?
Yeah, yeah, they're correct. They're correct.
Okay, sir.
I, as far as my remembrance, like I written all the things in the order so that, so x1, x2, x3, they're mapped together. This one, yeah, they're mapped in the order way, and the fourth one doesn't map. Yeah. So now, um, this from this point, like what we are knowing, these basins were actually the things, like the regions where they are sitting or talking very loudly, that um, how far, how they are remembering. And remembering is means that they are sitting in different plane, different convex, like convex shape. So as many as convex shapes we have, and as many as boundary points we have, then we can remember as many as as many as associations we can make it. That's what it is talking about. The memory associations is completely depends upon, like uh, the way the convex shapes are splitted, and how many convex with you think of, like the fundamental question: can two associations be sit in a single convex? Now that will be the trying to address. That's a kind of, like, think of like a question: uh, can uh, two uh, x size be sit in a single convex shape? That means, if they are, what if they are belongs uh, to sit in a single convex shape? Suppose if you get, if you try this one and x1 and x2, if you try again, it is also getting this one, then what do you say about it? What do you say about it? Like, could you able to associate the mapping, or it can't be associate? That's you think the question.
So if two vectors sit in same convex shape, sir,
Yeah.
then they will map same y.
Yes.
Then
Then.
there is no kind of associative mapping, sir.
Mm. Yeah, that is a kind of answering. And then now my fundamental question is, mm, so how do you think of, like, if you now for time being, if you think of something like, how do you understand these uh, polyhedral or concepts or convexity, and how this is this one? It is actually the concept. Whatever we are doing, 90% of the thing is actually is sitting inside the very early concept whatever we discussed in this. If you solve these exercises, you then you could understand, yeah, these exercises, these I have given some of these exercises, like classification, especially not the did I discuss classification, right, in somewhere? Yeah, right, yeah, this one. So these, have you tried this to solve these exercises, this kind of classification?
Yes, sir, some of them, sir. I have tried.
Okay, fine. uh, Now, actually, the convexity or the Bayesian attractions or whatever I am discussing, or the decisions, actually, the decision boundary, it is talking about which side, less than, greater than, or this one, this side. These are all the shapes. It is partitioning here as well. This side and this side. So the regions, whatever you are seeing here, these are the, again, the less than, greater than, less than, or the same thing goes going here. So that is the same, again, you have to you are using here the decisions, the points which are belongs to, right, the points which are belongs to which class, the pink color or green color, is falling into the which regions. So the same we are now discussing in the concept of memory associations. Again, this is all about, the association and Bayesian attractions, from which regions they map, and how do we understand them. And further, maybe I will give an exercise. Maybe it is an auto association. You try this one. Mm, Exercise. I give it in the red color. The same, but it's a auto, 3D auto. Now the x1 is 1 1 1, x2 is 1 minus 1, x3 is minus 1 1. Okay, auto means, so I don't need to give y1 y2 y3, those are the same thing. They are associated to themselves. And what we are finding, we may need to find out w. And once you find the w, then you will get a linear mapping. W means from that uh, uh, the you will get W, a 3 by 3 matrix, and that 3 by 3 matrix produce at max two eigenvalues, or not two, three eigenvalues. At max three eigenvalues you can find out. And once you get the three eigenvalues, you can see the now my question I will ask you here. You can, of course, see W is, finding the W is nothing. You just follow the auto association rule as we did earlier. W, how the memories sit in the eigenvalues, eigenbasis. I don't call it as eigenvalues. I sit in the eigenbasis. So uh, you get the W. From that, find the eigenvalues and eigenvectors. I don't call it as this one, eigenvalues, eigenvectors. Once you know the eigenvectors and eigen values, and you can get the eigenbasis, that means the space of the eigenvector, the which spans it. Of course, here it is one dimensional spaces. There are the three linearly independent eigenvectors. You get it. The three linearly independent eigenvectors forms three spaces, so that you will get uh, different spaces, no, three planes you will get instead of one two planes earlier. You will get something like pi 1 and pi 2 pi 3 from the three eigenvectors. Now find out the basins. uh, Now just find pi 1 pi 2 pi 3. I can say that these are the part A, part B. I can say this part C is uh, find basins of each vector, that is for I. Just know whatever you did the same way. I 1 2 3, for every x1 x2 x3 you find the basis of it. Okay, so you
Sir, in this case, we got eight regions, sir.
maybe you may I don't count it how many regions you will get it, but you will have a lot of multiple. If you have three equations and two, then do permutations, that number will associate like all possible combinations of greater than, less thans with the three equations. Okay, you count them. Yeah. uh, so these are all like uh, basins, basins of attraction, and how they are looking at it inside those living spaces. Those are called convex space shapes, and find them up. Okay, this is a like I'm chopping it out, this concept, because I don't want to go take beyond an extension level that is actually yeah, it is beyond the scope of the syllabus or beyond the scope of this one. How these are all like connected into artificial intelligence, that all those things maybe you can take up that level of further connections to machinery or further connection to intelligence maybe later. This is the think of like uh, the mathematical concept which is being used inside somewhere in the learning procedures or intelligence procedures. Okay, this is a fundamental core pieces, I could say. And yeah, mm, this basins of attraction, I don't think that in our syllabus having this kind of these concepts as well. Like only it is just asking describing this only hetero and auto associations, but I just wanted to extend a little until the basins, as you know already. uh, Okay, further, um, the auto is actually, I will write two comments on this. Uh, hetero and auto. Auto is a recursive, like as we have seen, like this one, we are taking into the system, and then the association again we are mapping backwards. I think I have drawn this one very beginning. This one, that means like we are trying to connect with the same one. That is what that recursive nature. um, so from this point of conceptual ideas, I just wanted to apply. Did I discuss something like Hebban learning, right? This is all due to the Hebban. I don't know whether I have mentioned Hebban learning or not.
Yes, sir. You have mentioned so.
Okay, okay, then that's good. Hebban learning. This is the concept of coming out of Hebban learning, and I think I have mentioned. Urban learning actually joins the xi and yi, the product with the input and output. Am I correct? Sometimes I use a different way. I'm not sure of writing all the time same. I just wanted to see. Where did I mention urban learning? Okay. Yeah, okay. These basins of attraction, the length cycle, all these things. These are all like to understand the basins of attraction. No, I did not mention anywhere urban learning. Somewhere, yeah, this one. Yeah, right. This one, right? So the weight updates the principle that always what is the learning procedure, always finding the weights parameters associated within the learning model need to be optimized by taking a right choice of this one. Okay. Now I just wanted to understand you make this one not only for this one. It is our core way of learning. Suppose if somebody asks you what you know about uh, the machine learning and how decisions are taken and what is the math behind it as a mathematics, you should be so strong that you bash with them with the principles of mathematics and how this learning is happening. So don't just uh, you should not be don't just be like a computer student. You don't compare with the computer science students, as I suggest you many times. Like this is the world of like the mathematics who those who know the mathematics very strong concrete principles, they are the winners now in this market. Even if you know the programming in a good standard, that is the only last part of it. So the problem with currently the market in the stream, especially in the artificial intelligence and machine learning, uh, that is actually facing a lot of stress in the sense like uh, it is cannot able to cross a boundary. The field itself cannot able to grow from the one point of this point. It is a kind of like stagnated and not able to achieve the results much as it expected earlier last 4 5 years before, like what the plans are made, and now after 5 years from this point, it couldn't able to break down or couldn't able to break through a lot of things because of fundamental things. If you notice, the first point is lack of mathematics and statisticians. The very few people are doing, very few. You can number them in the world, in the globe, in fingers. Those who are working really math behind math the things like if you take consider in India, I don't think that the jobs they are getting not based on the mathematics. They're just like taking it up and customizing the already existing algorithms, already existing models into their own core services, like developing a bot for their product or their web service or something. Or these are all like uh, they don't make any kind of progress in the artificial intelligence and machine learning, and they don't develop any models. These are all like already existing ones, already existing principles they are utilizing and customizing for their own services. But to see a progress, to develop a own model, this is not sufficient. This isn't no more required. There are a lot of people coming out of as engineers, AML engineers or computer science engineers. Still, they are doing the same task. But that is not the thing. That is not the world is required right now. It is the requirement. And I can see from this point of time, maybe in next couple of years, maybe 3 4 years, this bubble will burst. That means like suddenly a drop of curve come up, like it is a massive, like it is a massive crisis to the AML, due to the thing like companies are investing billions and millions, but they are not getting any revenue out of it. Companies are losing money, and financially the stress starts from there, and it is a backward propagation, and it will shake the entire landscape of AML. That may come any time of ahead. You have to face it, that too, the crisis, like you may have seen this kind, maybe you may not have seen the crisis, like you may google it, dot com crisis, like early internet days. The dot com was the same situation, uh, faced this, like too much, what is called investments are too much, market overhyped, and one point of time it was burst out, and the economic shape was came. The same thing expecting right now. Maybe I cannot say exactly the time, but it should be face those who are especially in the line of AML, or looking for the jobs, or looking for the career, or whatever. That should, you should aware of much earlier. That's what I'm saying. So to face, face that challenges, I can say only one thing, uh, to sustain in the field of this one. Um, Now or sooner, definitely, um, it is a advanced mathematics requirement. If you develop advanced mathematics, not not just the ordinary graduation or course mathematics, whatever you are doing, this will just build you the foundations. But really, are you capable of developing a model on our own using mathematical principles, not using already existing models, already existing things, already existing models, or modifying or something? Like I am saying, like don't use any SkyPy, don't use any what do you call scikit-learn, or don't use any PyTorch, without using any such things. And can you develop the from the core principles of mathematics? That is the question you should arise. If you are capable of such mathematical ground things, if it is in your hand, then uh, that is the point where you will acquire only through the understanding the mathematics very, the complete details of it. That is my stress point for you. So so you are in the great position, I could say, having the mathematics, a blend of mathematics and computers, and these courses or whatever principles you are learning, you just transform them into a realistic way by developing the models. If your directions are in the line of A and ML, especially. So now, coming to this one today, like um, I will just go out of this topic.
Sir,
Yeah, yeah,
sir, I have question in my mind after your this suggestion, sir.
yeah.
Sir, like most of us are studying ML topics and all those like image processing, object detection, and all those things, sir. I
Mhm.
also learning statistical learning, sir.
Yeah.
You said after 2 to 3 4 years, ML completely gone like back.
No, I don't say completely. There is a stress and it will burst. But there is a decline will come. That is sure of it. Experts are saying, I'm not just saying, many experts are believing, waiting for that point of time. But it don't go zero. I don't think of that. Yeah.
Okay, sir. Then what we should do, sir? More focus on mathematics, sir.
Yeah, of course. Yeah, it's like you have to unify your own skill set. Don't fall into the trap of everyone, what others following and all. You identify the potential crisis. Those may come in the future. Look the future much ahead and ready for it. That's what I could say. I'm saying. So, what skill set and what level of advancement can make you such a robust, a bulletproof version of yourself, so that you can able to face. Okay, that is what, like, I don't think like model constructions nobody is liking right now. Like, the model construction means model upgradation or customizing the models for their own services. It is everybody is doing it right now. Like, if you go and look at your seniors, or maybe somebody, those who joined 3 4 years back into the AML, and what they are doing, and they are just tied to a company, and they are just making most of them. I'm not saying everyone, like, very few, especially working on, and uh, especially working on developing new breakthroughs, like can be stretching the artificial intelligence field itself. I just wanted to make you sure, like, where you fall, like whether you will be end up with just managing the codes or managing this one, or whether you wanted to go beyond that. uh, like, you make your own model development skill. Even I don't understand, I don't know what's happening in the Indian market especially. It is a full trap. And the people, or the private or public or some, and they are utilizing the hype of this AML, and they are grabbing huge money from the courses, the AML courses, and the fees are like more than, say, for 6 months course, like it is 1 lakh or 2 lakhs, 1.5. Like, I surprised to see them. They are so low level, and they're just like opening the explain. Like, I have seen a couple of my one of my friend have shown me that in India how what market is, how this educational market especially fooling the students. uh, they are not, they even those who are they are so poor that uh, they how the for the sake of example, um, eigenvalue decomposition, how it is being transformed into the machine, how that is being utilized, that is actually that is even not explained or not given in a strong way that one can develop on its own. So the all these courses, what they are trying to do is, they are just straight away opening kind of like scikit learn or something, and writing up the model, the calling the libraries, putting the pushing the data into it, and making the objectives on top of the data, and just already existing commands they are executing, and just explaining the mathematics in just like a formulas. That's it. I surprised to see that, like, I expected something like building a model on top of the mathematics. What I am expecting, that is nowhere is happening. So don't fall into the trap of these courses or something, whatever who suggest you, or you may come across. Like, you wisely think on them. What I'm saying, like, you should develop the own skill. So don't think of like machine learning is not the management of already existing libraries. This is the finally, libraries are used for the purpose of services, but anybody can do it with a little training. It doesn't require any mathematics, or it doesn't require any hard level computer coding as well. Okay, that is the least profession or least job, I could say, in the AML. Okay, the top level job, or the what is the point of position job, the top level jobs, or could be, or like working on uh, developing new algorithms, and working on new streams where the potential problems can be solved which at all not touched by artificial intelligence, and finding it out the difficulties, bringing them and chopping down into the mathematics, and how to build a model architecture and develop the code independently for that architecture, and utilizing and the latter being utilizing and uh, uh, into that field, that model. So what are all connected to associated to that model, again automatically that will become a library, and that will be used whichever field can able to apply on top of it. So this is the field the people required to understand the to get the high level positions. These people are very few. I don't see anybody from India as of now. I don't know anyone personally. You may know or no, I don't know, but I see in the Western like uh, the Gemini co-partnered with this one Alphabet, Google, and OpenAI. These people are the recruiters. They are not like just the AML. Uh, the models they are trained, they are the core mathematicians, core statisticians. They know the statistics and mathematics in a sound way, solid way. So this is advanced mathematics you required. The advanced mathematics means the mathematics which you are studying right now in your courses. Advanced mathematics is not something beyond what you are, what is not in you, but when you are studying courses or something like this mathematics and all, you apply the core concepts knowledge, acquire them, and utilize when you are reading for them AIML to develop a new models. Okay, so now if I that's what like where I thinking this one urban learning. When I come to this one, uh, this like suppose if I ask you to do urban learning or something, if I give some problem or associative or classification problem, let me come back. There is a urban learning used much before started urban learning. The name, forget about the name, comes from the many context. And suppose yeah, take it this one, or maybe I will go with not the n. Maybe the circle one is the much good one, and yeah, this one or this one, yeah. So now, how many of you in your class, okay, can you explain or can you able to develop uh, a mathematical perspective, math behind this classification, and converting that math into algorithm, and algorithm is boils down to model. How many of you can able to clearly see this? Not just this problem, any of such two classifications. And not just for the only simple example what I'm saying, like any of the kind of two binary classification, and forget about hetero classification like multi-class, that one, that is the latter thing. And like if I reduce this one, the annularity or radius, yeah, if I do the pinpoints much closer to this one, and you may have very narrow bed, so that you may have to fill with a lot of regions, lot of lines, so that that line segments forms a kind of polygon which separates this one. So at least can you able to for this particular problem, can you able to write up the mathematics within our hand on a paper, so that mathematically these regions will divide. That is the what yeah, please.
Sir, for this problem, sir, like we have two inputs, sir.
Yeah,
We can use a simple neural network, sir, as you mentioned earlier, sir.
yeah,
making a hidden layer. There are for this specific, so there are four lines, sir. Using
Mhm.
the hidden neurons, we can generate four lines using the bias condition greater than. If the condition satisfying, then we can say these are the green points, and if the condition satisfied another, then we can say these are the pink points, sir. One hidden
Yep.
layer neuron we can generate. After that, we can optimize, sir.
Yeah, and that is fine. Like that is a point of you're talking in the model level of thinking.
Yes,
Okay,
sir.
model level of thinking, and you're straight away picked up the model and started it up. Now, why that is doing, and the training principle or rule, whatever it is, promoting the weights associated in that, you straight away talking that one, and the model construction. Okay, the model construction comes through some complete details of mathematical principles, right? That neural network or something, whatever. So this this one I have already explained in partial way, in a general sense, but like this one, now uh, the if a layman ask you how exactly it's happening, and if somebody asks you to, I don't know anything about this classification problem, and make me understand from the zero mathematics, so how that mathematics is converted into the algorithm, and that is how this model is doing. That transition is so important that, like the core principles of mathematics, you should not leave them in the like you should not hide the model. You should not hide the mathematics behind the model. So if you hang on the models only without touching how the model is driven by the mathematics, then it is a serious crisis. That's what I'm saying. So uh, the models are already exist, and why should you uh, what is the point of you again touching the model and doing the same thing, and you don't need to reinvent the wheel again. So but what you can do is understand the mathematics, how the existing models are working, and get the fluid of all the advanced mathematics or statistics, uh, and then you can play with that mathematics and statistics to develop new models. Unless you don't look at them, you can't develop new models. You always hang on models only. So developing a new model doesn't mean like working it out, um, or working out a principle from the model, and taking a version of another version of that one to it is working out for some other data. That is not a model construction. It is a kind of like same thing. You are working it off modified version of that one. So at this point of juncture, what I can suggest you, or what you can do it, and develop the model from the core principles. That's what I could say. So you don't need to code it. I don't suggest you don't. I suggest you it doesn't require any coding. Okay, no code. Like you forget about the coding part. Why I'm saying coding part? You don't need to worry about it. Coding is the last 10%, I can say. Last 10%. 90% is the development of the logic. Whatever model you take, whatever model you take in the machine learning or artificial intelligence, 90% is it's sitting inside in its core development. And 10% is the only coding part. I could say this is the program part. Okay. So you don't people are working on this 10% piece only, not on this 90% piece. 90% which is actually driving the model, 90% which is actually the fluing that one. Like for example, okay, I will just what I am talking, I just don't want to give these kind of things. I will explain right now, like to see exactly what is this piece and how this is transformed this one, and maybe you can connect very easily from this. So yeah, this is actually into this part of the course, but I have already given the part, things, but you these exercise purpose is that one only actually, whatever I
Sir,
given.
you earlier mentioned, sir, like if you have to separate two different regions, then you start 1 day, then you start 2 day,
Yeah,
and
yeah,
one how the mathematics works, sir. You have
yeah,
given earlier, sir.
yeah. This okay. I have given these things. Um, yeah, and these neural concepts and all, like for the especially for the classification, I have given some kind of like neural networks in general sense, like how they work, all these things. But this works for everything. Um, Let me give something like, let me ask you a couple of things. Why I come back here again? Now my question is this one: did you see urban learning there in the classification? This one. Did you see urban learning? Name doesn't matter, but this whatever wi is updated with wi plus eta times xi yi in classification problem. That is my question actually. What I'm addressing. What is this actually? What my point is actually, I told you when the time of learning, urban learning, it is a principle comes from the psychology, but it is independently can work. And how do you understand this one? So now if I write up a algorithm for the classification problem, let's take some classification problem. For time being, I'll just take uh, a kind of urban learning. So you have these red points and you have blue points here, and there is a line separating this one. And what are all things I could say? Here it is mm, the xi are the mm, xis are the points, like xi bar, that is a vector. It is what it is, like each point coordinate. This is a xi bar, that one. You have data like x1 bar equal to x2 bar equal to, and so on, and each one having its own label. That is, I can say that they are labeled as, I don't know what labels I given. I think it's a +1 or this one with -1. Let's say x1 is a um, +1 label and this one is a +1 label. Maybe x3 bar is a -1 label, x4 is a +1 label. That means like the color or the classification, and you have the several points, and with their own labels, +1 -1 are mixed up. Now this is the data, and now I simply say that you just run a for loop, and for loop uh, with for loop for uh, I equal to 1 to n for every point, and I could say that there is a uh, there is a line we need to find out. This is the line we need to find out. That line is itself, let me take it as L equal to W1 x uh, x1 plus W2 x2. That is the coordinate, like x1 x2. This is also like, these are all like um, first point for the second point, x1 x2 coordinates. This is the x1 and this is the x2 and plus b, the bias. Now this is the L. Now we need to figure it out, the right W and the right B, such that it separates it out. So find out W1, W2, WB. Uh, I need to update W1, W2, B accordingly the data. That's what you know it. So we write up something like W1 equal to, or W1 equal to W1 plus eta times, eta is some random number, and initially you may choose W1, W2 be some random numbers, and then you are updating so that the line is coming in between them. Eta times, this one is xi, I could say x1. This is the x1 for the ith point. Okay, and this is the label yi. Okay, for the index xi yi, that is like xi, the first coordinate of the xi point. I could say this one. And w2 is w2 plus eta times the xi point of this one, the second coordinate of each point. This one is, okay, maybe I'll modify this index something. This one x1 with the first coordinate, x2, no, what I'm saying, okay, is a x1 with the second coordinate, that is the point description, x2 with the first coordinate, x2 with the second coordinate, then so that matches here. Xi yi, the first coordinate from the x bar, and this one, and b is b plus eta times, can anybody tell me what is eta times?
I Y sir.
Not xi yi, only yi.
Only Y sir.
Yi.
Yes sir.
Yeah, then just simple algorithm, this one, right? And this is nothing else, it just classify, it just finds this line. So now, how many of you know, and this one, how these simple lines are decision making, working it out? This is a urban learning, what I am saying, where I started, this is a urban learning. It is also there, but this is a one here, actually 1 into y1 in terms of xy. Yeah, this is updating and finding it out the line, and then this is being developed into the model, and it is working it out, and it is classifying, and it just we have done it just only for this 2 point classification, but it can be worked for the circle whatever we have shown, and for multiple points and all. Instead of just L, and you take L1, L2, L3, multiple same, but updation principle is same again there as well. Now tell me, uh, make me, or convince me uh, how these rules are making to find out this line. What is actually mathematics is sitting there?
Sir, optimization sir.
Yeah, optimization is there. The names, like from where we, can you derive these lines? How they come up? So actually, what my point is, like, even if you finish your BTech and with mathematics and computers and having multiple knowledge on AML, and you couldn't able to answer a simple classification problem, how this algorithm simply does the job, and if you cannot give this one, the meanings behind this, how actually these weights are updated such a way that this line is produced. I don't think that uh, that would be a good state of hmm, state of uh, what do you call the justifiable knowledge. You can give it for your learning process. So that is kind of like, you should not be pushed or put into kind of embarrassment of knowing the degree, having the mathematics and computers, but cannot able to give a simple, it is a simple entry problem. I am not saying advanced problems and all, these are all like, connected each other. Yeah. So now why I am saying all these things, you think of like, don't think of like just understanding the models and knowing the algorithms, knowing the formulas is not the thing. That is what actually India, especially, I could name this one, is far, far, far lowest point in the development of AML. I don't see companies are recruiting graduates to develop the models, to engineer the new models, to understand, to interviewing, or to grab the knowledge pool, those who and those who develop really the mathematics, so that it can break through new models. That's, I don't see any company. I'm not sure of if it is anything which is doing, if you know, but so that is a very sad part of it. But
Sir,
anyway, yeah,
sir,
yeah.
here, sir, we can say why this equation comes, sir. Here,
Mm,
line equation you have written W1 x1 and
yeah,
W2 x2 plus b.
yeah.
Whatever we change we in x1,
Mm,
the W1 affects the times
mm,
our y output, sir. Like
okay.
how I can say.
Mm,
Uh, so like if we take y equal to ax, sir, so whatever a means rate of change of y with
mm.
respect to rate of change in x, sir. Same way, whatever rate of change in y, how y changes if we change our x.
No, no, here is y is the label actually. Don't misunderstand. I
Yes,
mean, yeah, you
li-
y is the label is just a plus or minus one. It doesn't change. It's a fixed thing for everything. And the xi's are the things. Xi1, xi2 are the coordinates. Y doesn't change. Y is the label. Is a fixed. That is fixed for the point. Y doesn't change at all. This x1 and x2 are the point coordinates, and for each point it is a different thing. This I is running from 1 to n, that is through the data means for every point it is running, it is picking up x1 and x2 for every point, and w1 and w2 are adjusted according to this rule. So now the fundamental rule is, can you develop these rules?
sir, can we use this same logic in like if we don't have classification, we
Hmm.
have continuous problems, sir, like y is changing. Should we
Okay.
use same logic, sir?
I don't think that is not the thing here. So, suppose this problem, if these rules are not given to you, how do you develop that? It's my point. Like, if some problem you have seen, like, think of it like the rules are already presented in front of you, so that you can interpret in different ways. You can interpret in multiple ways of, okay, this rule may come up like this. These are all developed in such a way that it do the problem. But the problems which they are not at all framed the rules, and that had to be developed from the mathematical perspective and bring it down to the rules to solve the problem. Uh, so that construction of journey is important to this making. Okay, I will take you a little journey, maybe 10-15 minutes, so that uh, so that you will be understanding how these are developed. Like I will ask some basic questions, very fundamental mathematical questions, which will be easy to construct. This is not a simple thing, not a hard thing. So suppose let me take a blue point here and a pink point here. Let me label them as it is a plus one and it is a minus one. Simple 2 points. I'm not taking too many points. Let me take a line. Okay. This line is line equation. You know line equation, right? Line equation. Let me take it as a w1 x1 plus w2 x2 plus b. So this is x1, this is x2. I am not taking x and y as it is a convention in the mathematics, but x1, x2. The advantages is that we can extend this one into higher dimensions so that the indices can travel x1, x2, x3, x4, and so on xn. That is the advantage instead of x and y and g. Yeah. So now you have L this one. Now tell me, on top of this point on this line, this line L, these are all like the points on this one is L equal to 0, right? And one side is positive and the other side is negative. That means L is greater than 0, L is less than 0. You agree that?
Yes, sir.
Yeah. So tell me now, first question I will, why? How do you say that? Uh, why L is uh, greater than 0 or less than 0 on each side of it. How do you say that? Do you know why?
So collection of all points on the line, it satisfies the equation. That means equal to zero.
Yeah,
If
that is
we
true.
if we don't take any point above up, apart from the line, so if we take any point, that means there is some value. That value may be positive. That value may be negative, sir.
Yeah, that's sure. Like the
Then
line equation itself, the line equation w1 x1 plus w2 x2 plus b equal to 0 we take so that it forming a line. It is a function as L, it is a function, but
yes, sir.
as an equation, it is a line. Yeah. So as a function, it can have any value, either 0, positive, negative. But if it is 0, we are getting a line, a geometry line. And now the question is, on the point which you are substituting or the collection of points, zeros which gives they are on the L equal to 0. Now my question is why? The question is, how do you say that L is positive and L is negative on either side? Why can't it be negative also sits there and positive also sits there in one side? That is the question number one, I would say. Okay, let me take a simple example like 2x plus 3y. Uh, okay, before going to an example, I will ask you something like you have a line equation like this. Let me draw a line equation. I am not drawing any point and all. Now I given a line. I did not give the line equation. Okay. Now tell me, this is a geometry line. Now tell me, yes, assuming that you know that one side is positive, one side is negative. This question is, you know it already, I'm assuming. And for this line, I did not give any coordinates from where it is passing and all, but I just draw in geometry and saying that it is the origin. This is the xy coordinate. And can you tell me which side is positive and which side is negative? Or this one, or this one? Can you tell me without line equation? But the geometry is given. Or both situation may possible for the same line. You understand my question? These are the plus two questions. I'm not asking the engineering level question.
Yes, sir. So if we, so in this case, this side is like origin side is positive, and so origin side is negative, and this side is positive, sir. Below the,
Okay, your answer is like origin side is positive and the
no,
below
sir,
side is
negative, negative, sir.
okay. Origin side is negative and this side is positive.
Yes, sir.
I don't give any line equation. I'm making sure that only the I have drawn the line equation. Some line is passing just like this in the cutting the third coordinate, uh, the negative x and y axis, and this is you are talking about it. So yeah, this is actually you need to break down the conceptual things here. Like what I would say, the answer you will understand very soon. Like let me take up something like 2x plus 3y. Now I gave some line equation 2x plus 3y plus I'm not giving the b equal to 0. Okay. For that, can you tell me how this line can be anywhere? So can I take that line equation like this? I did not give b. Okay, but that line can be passed from anywhere.
Yes, sir.
uh,
Yes, sir.
Anywhere. Now, uh, but it is giving something like um, the slope only I can guess it, like somewhere it is sitting this way, not this way, right? Now tell me, can you tell me this which side, either let assume that this line is this way, and which side is positive or which side is negative for this line equation? Let me take this one into somewhere down as well, no problem. Which side is positive and which side is negative?
Sir, if B is not fixed, we can't say, sir.
If B is not fixed, we can't say this line. Can anybody guess it? Not just you. Anybody's there? All of you. It's not for just one person. It is simple mathematics I'm asking. I'm not asking something uh, engineering level, but these are all the basic things to which leads you to solve these equations. So come to that one. But here, as you said, like earlier, like you have here it is no equation. It is there. You could able to guess it. But here it is some partial equation is there. You can't able to say.
In previous one, that is wrong, sir.
Okay.
That
Okay.
is wrong. Because reverse is correct, sir. Like
Oh.
in that case, sir, if we
Okay.
take ax plus by plus c equal to 0, if we
Mhm.
put both equal to let x equal to 0, our intercept is negative. That means y plus our L value is positive, sir. If we put both x 0, sir, then that means that side should be positive.
So this one is
And
L0 and this one is greater than 0. Your answer now.
yes, sir.
Okay.
That shift line, sir. If we're changing the line, sir, we can't say, sir.
No, no, the same. Suppose geometry is that one. Same geometry. I'm not changing. So okay. We will see. Yeah. Now tell me for this line equation, which one is which one? Which one side is positive and which one side is negative? Suppose, yeah.
Same answer.
Hmm?
Same
Same.
answer. Yes, sir.
Same answer. Okay, now let me change a little bit. Same line equation can be expressed as uh, minus 2 minus 2x minus 3y plus b equal to 0. I can represent the same line equation as that one. by changing my sum b. Same line equation, but I changed my b. Now then it need not be the same b here as earlier, but the same line, geometrically same line. That means that it is passing through the same points. The set of all points on the line, I can express either this one or this one by changing the b. B is what b actually do. B is actually just shifts the line, right? So that maybe it may give some other line, but it is I'm just shifting, changing my b so that it is comes up and down. Yeah, please.
Then, sir, if we change the B in this case, sir, then our lines shift to uh,
No, line is not shifting. I'm saying that I adjusted b such a way that it is representing the same line because I can express that one. See, it is both the set of all coordinates collection which satisfying this one, and for this one also same. That means the same line geometrically, but equations are different. Equations are different means equations are also almost same, but they are represented in such a way that two different forms. Okay, I think I should. Yeah,
same answer, sir. I got.
same answer. Okay, this is greater than zero. This is less than zero.
Yes, sir.
Let's see why. Think of this one like this line 2x plus 3y plus b equal to 0. What is the vector, the coefficients, this one and this one, that is the w bar, that is 2 comma 3. Now point out this 2 comma 3 vector, 2 units in the x direction and 3 units in the y direction, that is this one. Okay, and somewhere like I will mention properly this one. This is 2 comma 3. This is 2 comma 3. And now I claim something very strong, which you should collect our school level or college level mathematics. That the line, the vector which is grabbed from the coefficients of the x and y, ax plus by plus c, or this one, the coefficients here, the line equation the line equation the I mean the geometrical line and this one, the vector pointing this one, these two are perpendicular, you know that. That is another question for you, maybe you can recollect. The question is the coefficient vector w bar is perpendicular to l. Why is also address. Okay, and another claim or question I could say, the line the line this is the line this I'm saying that this line is perpendicular to this w bar. um, the line equation produces positive on the side of the direction, the line equation produces negative on the side of this one. Okay, l is question is uh, l is positive if L is positive, not if L is positive on uh, on W bar direction. L is negative on um, minus W bar. That means opposite direction. Y again. Okay, that means like the line is producing positive this side and line is producing negative this side. You don't need of the b value. No matter somebody is give you and ask you which side is positive, which side is negative, you don't need of b. You just need pick it up and just think of like what kind of point where it is pointing and which side is pointing. Then you can say immediately that it is a positive side or negative side. For this equation minus 2 and minus 3, then immediately it points this side, that vector for the same line, then the signs are different. So the answer we cannot say if you don't know the equation, especially the coefficients W1 and W2, we can't say which side is less than which side is greater than. Either it can be possible this one or it's possible with this one based on the direction which is pointing for the same line. So now if the same line is taken, but if the vector W is pointing this side, then it is positive and it is negative. Okay. Now there are a lot of questions. You think of it like I am writing simply the y. They are not just y's. You should know them very concretely and solidly as a mathematics. Okay, as a mathematics ground, you should not leave them these y's very easily.
Sir, for this perpendicular, sir,
Yeah,
I can say,
yeah,
sir, if we just let put the b equal to 0, like sir,
mm,
bias
yeah,
adding
exactly.
constant means just
Mm,
same the sir sliding the
mm,
y with
mm,
fixed slope, sir.
yeah,
If we put b equal to 0, it
mm,
passes through origin. Then
yeah,
our coefficient, our what coefficient vector also doesn't change. Then
mm,
we got one equation, sir, w1x plus w2y equal to 0, which
mm.
is a dot product equation, sir.
Dot product equal to zero. That is the one interpretation you can say. That is,
Yes, sir.
yeah, that's very
That's
good.
why that will be
Yeah,
perpendicular, sir.
they are perpendicular, and that is not a proof. That is an interpretation, so that you can extend b so that it just the line equation just moves in this way, but it doesn't change the angle with the vector. It always maintains the perpendicularity, right? Yeah,
Yes, sir, that's what I am saying. Yes, sir.
yeah, yeah, fine.
And for
Hmm,
second, sir, why in that direction always positive?
hmm,
Uh, Vector, sir, that coefficient vector means, sir, I am just
hmm,
interpreting, maybe it will be wrong, sir.
hmm,
Uh, Coefficient vector directions means, sir,
hmm.
in gradient direction, sir, change, sir. Then that gradient direction always increasing, that's why
I don't understand
that
what is gradient. We don't have any gradient things or any derivatives here, nothing. Uh,
the gradient, why I'm saying gradient, because it's perpendicular to our
no,
line.
no, no. We don't. Gradient always is a kind of like talking on the rate of change of something. The gradient means.
Yes, at that rate of change.
Yeah, we don't have any rate to talk. What is the rate here? What is? We don't have that thing here. If anybody like, I don't know who are all present there or not. These are all like you should aware. It is core principles which is driving the models. So without knowing these principles, you can't at all, you can't touch these things. You can't derive, or you can't able to understand them, these lines, this urban learning. So now you should know like why this is positive, in the direction like simple, like you may feel like something is 2x plus 3y plus 1 equal to 0 is a line equation, and the line is producing in the direction 2 comma 3, it is positive, and the line it is opposite, it is a negative something. It is saying very strongly that you should look at it like I can just think it comes so naturally.
So like if we put the same direction, then we got like if we take the point in the direction of coefficient vector, we got the another vector. That point represent another vector, which is in the same direction. Not always we can say same direction. One component is always in the direction of coefficient vector.
Mm,
Then product of like in the same direction of two vectors,
mm,
which it will be always positive, sir. That one I can say, sir, based on that.
mm.
Like if we take any point in the direction of the coefficient vector in that plane, it's just like from the line it create one vector. There are two
Okay.
component of that vector. One component is along the coefficient vector, and other
Mm,
component is along the line vector.
mm, mm,
In that way, sir, if we multiply the two vectors in the same direction, both are, then resultant will be positive.
mm.
That way, I can say. Uh, Or if we multiply negative, like the cos, if we the multiply the negative, like just opposite, then sir,
Mm.
there is a cos angle between those two vectors are pi degree.
Okay, okay, okay.
I am just talking one
Yeah,
component,
understand. Yeah.
which one is along the coordinate vector, sir. Another component also should be along the line vector.
Mm. So, uh, okay, you just let me look at this one. L is this one. Where here, like not this one. On each side, coefficients. Okay. Yeah, why this one actually? Why this one is other side and the same thing? You can answer it. Why one side is positive, one side is negative, and that maybe is a simple thing to answer. First thing, um, you have something like this one, and you have a line equation L, and one side is always positive, or one side is always a
Sir,
negative. Yeah.
I for third question, sir, now I can say, sir, like
Mm, mm,
whatever point which we taken the
mm,
uh, in direction of coordinate vector,
mm,
there is angle, sir, between that new point vector with coordinate vector.
mm.
That angle theta always 0 to pi by 2, sir.
Mm-hmm, mm-hmm. So,
That's
okay, I will come back to that angle concept is actually sitting there, but that is actually producing the learning algorithm. Before that, like, what can we say from the very fundamental principle? Like, if you take a point one side, let's say this is, and let's say a point on this one x0, let's say x0, if a point on this one x0, and we have a w bar this side, and uh, now if you apply something like uh, this w bar is a vector. If you consider like this one, w bar is a vector, this one is a vector. um, Now think of like uh, think of like suppose you have a point here, something one side of this one. So this point is something like x1 bar. I think this is x0 bar. Now can you express x1 bar equal to x1 bar equal to something like w bar plus t times x0 bar? This is a simple thing. It's a linear combination because of w bar and x bar are the same. And so uh, so that if you choose any x1 on that line, any x1 on the plane, and you have w bar and you have x0, and there is a linear combination or something like, if it is perpendicular line, let's say there is a perpendicular line here like this. On this blue line, if you choose any point that is in the direction of w bar only, x1 bar, this point is the l is perpendicular to this one and w bar is also perpendicular to this one. And now it is how much it is away, that is a t distance away from this, from the x0. So that is t units, t units from the x0 and in the w1 direction. You understand this one? The simple,
Yes, sir.
the
Yes, sir.
vector addition, right? How I am writing that t units away from I'm sorry, like, oh, this is not the correct expression. Why I'm writing this. This is t units in the direction of w. That is, you can express as x0. You are taking t units in the w bar direction. The t and this is because this one is perpendicular. Yeah, this is and this one are parallel, and x1 is constructed from x0 bar plus t units away from the w1 direction, w direction, right? This x1, this one x1, you are fine. This is, you don't know, you are constructing an x1 which is some side, either that may be this side or that side. I don't know about that one. I'm just randomly chosen one side x1. This x1 bar is being constructed from the point on the line plus t times of w bar. That you agree? You can travel to x1 by using this x1 and w by some t units in this direction, in the direction of w, right?
Yes, sir.
So this is a vector addition, that is by principle. You are traveling from x0 to x1. That is the new can be written as in the direction of w. That is this one. So now if I apply the L of the value of x1 bar,
Yes, sir. It will come a square plus b square. It will come
yeah,
positive.
yeah, right, tw bar, then what it will come? This cell, if you apply line of x1 bar, you are applying line of x1 bar, you are substituting that one. That means w transpose x0 bar plus t times w bar. That's the point substitution. That is, you know
Yes,
that
sir.
L of x bar equal to w transpose x bar. That is the line equation. Plus b, of course. There is a plus b. I will keep it as plus b as well. After applying the line equation, that point, you should convince yourself like there is the smooth understanding of the vector addition of that one. Now multiply this one. What is happening? W transpose x0 plus t times w transpose w plus b. Now if you think of w transpose x plus b, 0 plus, I am just putting the plus with the first one, b with that one, and t, it's a dot product. You can write off this one is the norm square.
Yes, sir.
and this one is 0,
Yes, sir.
and the t times norm of w square, it is it is positive when t is positive, if it is less than 0 when t is less than 0.
Yes, sir.
So when t become positive,
In the
if you
same
are
direction.
traveling in this in the traveling in the direction of this one, it is a positive w direction, and if you take t equal to 0.1, then you are traveling this much here in this side, in the w side. If you t is negative, something like -1, you are traveling this side, your x1s are sitting this side. So when t is negative, the values of l are negative. When t is positive, and the values of l are positive. So the points which are, that means that the points which are side of the w bar are producing positive, the points which are siding this side are negative. You understand this one? Yeah.
They are the solution of all three questions, sir.
This is a kind of like a proof, we can say, that always why the positive in one direction and negative in other direction based on the w bar. The coefficients are directing actually. You should not leave that. Okay. So this is a first principle, one thing you could say. Now tell me, yeah, I think this is cleared. L bar is why this is in the direction of LW bar direction, and why it is in the negative in the other minus W bar direction. Got it right?
Yes, sir. Yes, sir.
Yeah, that is what we are saying. So that means like further extension, this one, it is in the side of W bar direction, it is in the side of minus W bar direction, right? If I can say completely. So that is our positive and negative. Now my further things from this point, like you have something this one line equation. Now you know that this is deciding. Now this is what it is deciding. W bar is the thing, this one. Now tell me, let me choose w1 x1 plus w2 x2 plus b is my line equation. I don't want to change b, I just keep the b as it is for that line. Now tell me, before going to that, touch this one, my line is this here now. Now tell me which side is positive and which side is negative. Which side of this line is positive and which side of the line is negative.
The W bar is this one, sir. Then above side is positive, sir. Below side is negative, sir.
Exactly.
Yes, sir.
Yeah. Okay. Um, Now tell me, in this line equation, L equal W1x plus W2b. Now, if I wanted to change, I don't want to change b. I just fix this one as it is. B is not changing at all. I just wanted to change W1 and W2. Um, okay, W1 and W2. What will happen with the line? What it will do? It will, what it will do if I change W1 and W2
Uh,
simultaneously by some amount?
it, sir, it fixed the intersect point and we rotate the line, sir.
Intercept points we cannot fix it actually. You don't know that's, but assume they will rotate. That's I agree. They don't
Yes,
fix.
sir.
If the intercepts are fixed, then line
Why
won't rotate.
only Y intercept, sir? Only Y. I am saying only Y
Y
intercept.
and will intercept also don't change at all. That's, they don't change. The ratios maybe they behave same, but the intercepts don't fix. Okay, don't think of like the axis of symmetry, axis of rotation. You are thinking. Don't think of the axis as of now. Axis has a lot of things to do. Now, now question is about, uh, suppose, okay, um, like, uh, let me, before touching that one, I will introduce the points. This is the time I can introduce the. There is a pink point. There is a blue point here. Okay. The pink point is labeled as +1 and the blue point is labeled as -1. Understand? So now I will formulate a rule that already the L can be positive one side and the other side is negative. I have my labels. I have my labels as one is +1 and other one is -1. So I have a lot of choices I can take. Either I can take -1 here or +1 here, but I wanted to stick with. I just wanted to give a line. My positive label should be on the positive side of the plane, this one, and negative label should be on the side of the negative plane of the lane, so that my labels are y1. This one is y, and y is the label, and the L, the share, the value of the L is positive on this one, so that I can multiply y times L of x bar, you can say. So that is always positive because of, for the pink point, my y is plus and my L of x, it is plus. It is greater than 0. I don't say it is, it's a greater than 0, so that positive times positive is positive, and y times, for my blue point, my y is a negative, and this one is L of x is also negative, so that it is also positive, right? Understand? So I am defining this one some kind of a rule, so that I can able to bring my line something like this, so that these two are satisfying. This side is a negative and this side is positive for the L value, right? So my pink point, my blue point is -1 and this one is a negative, so the product of these two things are becoming positive, and the product of these two things are positive, and I just wanted to push into the positive so that I don't need to worry about it. So now I can say that if you have the data of something like xn, and with the labels yn, they are labeled +or -1 uh, for every data. These are all two sets, and they you have n pieces of data, and that means pink points and blue points. Now I can say that if there exist L, if there exists line equation, that means L means what? L is controlled by W1, W2, B only. The line is controlled by this one. Yeah, L is controlled by this one. If there exist, I can remove. If there exist W1 and W2B, such that uh, the labels yi times the L of xi is greater than 0 for all I, then we can say the line corresponding to W1, like the line corresponding the line W1 x plus W2 x2 plus B is classifying the points. You understand this statement? This rule, you understand why this is? Suppose if a pink point is here, then this let's say it is a x3, x1, this is a 1 point and this is a 1 point, this is another point, you keep pink point here, then for these 2 points it is satisfying this line equation. This is a +1 and positive, and this -1 and a negative, so that both are positive. But if a pink point is here and whose label is +1 and L is a negative, +1 with the negative, it is not doing with the greater than 0, so that we cannot say for that particular point it is not satisfying this one. So if for every I we can able to bring down the label times the positive side or negative side according to the label, and that means the label and whose score or whose value are the same sign, then we can say that that line is perfect for that point. If it is there in opposite signs, like it is a plus one and it is a less than zero, then we can say that the label is the line is not perfect for that. That is misclassified point. So if a pink point is hitting this one, then according to this line and that principle, this is a this label is positive, but it is sitting inside negative side of the line, negative side of the line, so that it is misclassified. So positive points should be sitting on the positive side of the plane, off plane, and negative points should sit on the negative side of the line. Then we can say that this, suppose if you cannot able to find out such w1 w2 b such that for all i's it is satisfying, then we can say that that problem is not classifiable. Understand what is the definition of classifying? A problem is classifiable when there exist these parameters. So now we are very close to bring the rule now. What is this? Can you connect the where we started and where we are heading? Now let's see how we can able to. You have time or not? I'm not sure. We can
Yes,
finish it
sir.
up. Yeah,
We can extend, sir.
yeah. So now let's say this is a line and this is a W bar, and let's say my pink point is this side, and also my blue point is also, let's say, this side. My blue point is also this side. I don't remember pink point. I think, I guess I given minus plus one, and this one is minus. And which point is not classified properly now in this diagram according to our
Sir,
rule?
sir, this blue point is not
Not
classified.
classified. Yeah, blue point is not classified, and pink point is classified because the pink point is on the right side of the positive space, positive side of the line, and blue point is uh, negative label, but it is sitting on the positive line, positive side of the line. But what to do that? What we have to do? We have to bring our line into somewhere this one. Then it can be classifiable, right? Now, to do that, our
Yes, sir.
existing line having some parameters W1, W2, B with us. Some W1, W2, W3, some random values are this one. Now we need to update this one, W1, W2, and B, such that it will be shifted towards blue point and it crosses blue points, right? So what are all things should come here so that it will do. Now, in our hand, I have a what is in our hand to do that? I don't know what is this. The rules are, we need to develop those. We need to put them. So, what is in our hand? In our hand, I have a direction W bar, and I have mm, a B, the BIOS, and
And the data.
I have a data point that is misclassified. That is, I can say that a blue point. I can keep
Yes,
it as a blue, B as a blue point here. I will keep capital B, so that blue point, and whose label is minus one. This is in our hand now. Now, if you observe very carefully from the picture, uh, so our target is to push this line towards minus one, not away from the minus one, right? So if I away, then I cannot able to classify. It is just go away only. I just need to travel my line towards this one. I can rotate either this direction or this direction. But for this problem, I need to rotate in this direction, right? So how can I rotate that one? I cannot rotate. I cannot rotate the line. I can rotate my W. If I rotate my W, accordingly, my line is also rotate because they are tied up in a perpendicular nature. Understand?
yes, sir.
Which side I should rotate? And this side or this side, clockwise or anti-clockwise?
Sir,
To
anti-clock.
Anti-clockwise, right? I need to rotate this one into anti-clockwise rotation so that my line should cross this one at some point of rotation. Now, how much I should rotate so that it just crosses the line so that I will satisfy? I am on the safe side. That means I just wanted to bring into at least it touching and crossing little bit, or at least I should go in that on top of it. At least it is on the boundary. Okay. For that, how much I should rotate this one? How can I use the help of this blue point to rotate that? Now the who is guiding to rotate? Rotation.
Sir,
Yeah.
sir, I have one doubt, sir. Why in this we can't consider pink point, sir? We should consider or not
Which
pink
one?
point because pink point x which label is plus one.
It's already classified. We don't need to worry about it.
Yes, sir, I have doubts if we don't consider, then how we put the constraint, sir. We can rotate
No, no,
out
no.
of the
Okay,
pink
we
point
are always
also,
checking
sir.
for only one by one. Let I understand your point. Like, suppose if there is a ping point here. Okay, I understand your question. If there is a ping point there, and if you try to fix this blue point in that way, ping point is misclassified, right?
Yes, yes, yes,
That may occur. In such case, we need to understand. We have to consider ping point as well, as you said.
yes, sir.
Otherwise, some of the pink points on that we are as we are trying to fix the blue point, and some pink points may get misclassified. That is natural. That will happen. Again, we will come back and we will try to fix it up that too as well. Like it is a single time adjustment. It is the iteration procedure. Every time, that is what if you see algorithm, every time we will check for this one for I equal to 1 to n individually we are checking. For loop is running is for each point, and again this entire for loop sitting inside an epoch, and epoch runs for several times. So for every time it tries to get a closer perfect w1 w2 b such that all these things were classified. If we cannot able to find out, then it will be misclassifies and it will say that these are the points max I can classify, and these few points I cannot misclassify. We can throw that according by checking after certain epochs. We can check that for. So for instance on the core level, it is checking only the updation is only on a particular point. You think of it like only one point we are fixing every time. You understand?
Yes,
For an
sir.
updation we are checking only one point. In that process, by checking one point, fixing one point, some other points may get misclassified. That is natural, but that will fix up in the next iteration. Okay.
That's why we iterate through epoch also.
Iteration goes for several times, and epochs
Yes,
we
sir.
will do that. Don't think of like if you run for all the points one time, it is not possible to fix. Suppose if you try, suppose you have n points, n minus 1 points you fixed well, and when you try to fix the nth point, last point, and it may misclassify already fixed points. Already you have adjusted earlier, and that may get again misclassifies. So then you don't think of like one time run is not sufficient. Again, you have to run for epochs, several epochs. That is the what training epochs does the job until it settles all the things. Okay, that is the next part. Now, that's why we are core level. We are trying to fix only one point. Okay, yeah, you understand? You clarified? Yeah.
Yes, sir. I understood, sir.
Yeah. Now, let us know how much I should rotate. Now our target is to, okay, for time being, keep the b aside. I will treat the b separately, and because of rotation involves only, we are currently involving with the w vector only. I need to rotate the w vector such that it will cross this blue point. How much I should rotate this w bar? I have something in my hand, this one x bar as well. This vector also I'm drawing. Let me name it as x bar b. So what operation, what a vector operation I should take w bar and xb bar such that my line is travels towards xb bar. This is a simple plain vector operation. The vector, you can think of like vectors, vector, simple plus 2 vector calculus. Can you guess it? Like, please be involved, be like, the keep your brain full effort on this. This is what I am asking, like developing model formulas, model rules. What? Now tell me, how can I rotate my line such that it crosses XWRB and fixing the point, such, what I should do with the W? Then I can fix the formula. My formula will ready.
Sir, if we want to rotate the any vector,
Hmm,
then we should multiply with a different value in their components. That like if you multiply same value in
hmm,
both component, that's not rotates. It's only stretch, yeah, along like what expand in same direction. If you
hmm,
multiply different value in their both component,
hmm,
then that will be sir rotate, change
hmm,
the direction, sir. Like if we did take the two component, one component is y, one component is x, sir. If you
hmm,
multiply the same constant,
hmm.
that it only maybe stretch, maybe compress in the same direction. If we multiply in different constant in the
Yeah,
both
different.
component,
Of course,
uh,
they are
uh,
different. Then only it will rotate. But
rotate.
who will giving, who is who will deciding to rotation? That is, rotation is the xb must be the thing should rotate towards that one. That is the only thing. The rotation should give by this dax. This blue point may be sitting somewhere here or somewhere there, some maybe here. We don't know where xb is sitting. We randomly chosen here, okay, but it can be anywhere, right? Yeah.
Yes, sir.
So
Yes,
that should be guided. How xb is guiding to rotate w such that the line crosses that. So we are away from this xb. Now I can think of some simple vector calculus. This is the negative x bar b
yes,
direction.
sir. Yes, sir.
So now if I rotate towards the w bar towards xb bar, then I can move this one, the line into this xb bar.
Yes,
If I
sir.
rotate towards this one, I don't know from not exact. I'm just saying, I'm not saying that w should be this one. I'm somewhere in between so that it will rotate across this one, right?
Yes, sir.
Definitely that's towards the minus xb bar. So how much I should rotate? That is my question now. How much I should travel towards in this direction? So what is the towards of a point first of all? Suppose if you given two vectors and saying that, like, let me out of that situation and let me give some come to plus 2 level calculation vector chapter or something. Suppose if you may have already read this one, a bar. Let me write small one. Yeah, it is a bar vector. Let's say it is a b bar vector. Now if I wanted to draw a vector in between this a bar and b bar, I have a lot of vectors in between them. If I randomly if I wanted, that means like, if I want, this is my goal, this is my vector, the point, I don't know how to go that. So if I wanted to achieve my that one, if I wanted to achieve this one, how can I achieve that? A is
Decreasing the slope, sir.
no.
Ratio.
That means like I just wanted to uh, keep my A B towards B, right? Something what operation I should do here so that I will get it here. So simply, if you take, let me erase this one, and I will give couple of instances so that you can understand that. Suppose if we have A bar plus B bar, that means what? A is in this direction and B is in this direction. So you will be end up here with A bar plus B bar, right?
Yes, sir.
This is the a B bar copy you are taking here, so that A bar plus B bar. And the two times of B bar is this one.
Yes, sir.
Three times maybe that one. Point one times maybe is much smaller than this one. Like this one on sorry. Point this one.
Yes,
Point
sir.
one time B bar. Point two times B bar is this one. Like the way you take the scaling of B bar, automatically it scales here. So what it is parallel. It is parallel to the B bar. It is parallel to the B bar based on the quantity of B bar you are choosing.
Yes, sir.
That is what A bar plus something like T B bar I can write up.
Yes, sir. Yes, sir.
Anything. So whatever you choose, the vector, it is always traveling towards B bar only
Yes, sir.
based on the T.
Yes, sir.
Yeah, always it is traveling towards B only. It is nowhere that means like what the resultant vector always like if you choose what the choice of T is always making you the towards this one only. So as you choose large ones, it will go travel towards B. So the journey A to B is always can be represented as this one, A bar plus TB bar.
Yes, sir.
You agree that the basic vector addition. With
Yes,
the
sir.
T is controlling how much travels. The same thing you can apply here. The W bar should travel towards this one, and so
Yes.
that I can control my XB bar with this one.
Yes, sir.
So what is this? That is the W bar
Plus
plus
T
addition.
plus
The T times here I will take instead of T eta I will take eta times and
minus XBR.
minus XB bar
Yes, sir.
minus XB bar this one.
Yes, sir.
So my W bar, new W bar must be that means the new W1, W2, both are sitting there within the W. So travel this side only, the line travel this side for some point of rotation, somewhere in the rotation, some for
Yes,
eta.
sir.
So I need to find out a particular eta such that it rotates this point so that my line crosses this XB bar. So that is XB bar is deciding here. So that now I will get it. So how can I write up this one? Clearly W bar is updated with W bar plus eta times XB bar.
Into
That
Y.
means my blue into the label we are directed -1 due to this one.
Yes,
So
sir. Yes,
that is why
yes,
now
sir.
see this is the only principle we are looking
Yes, sir.
in this.
Then
So
yes, sir. We can separate also.
now you got related how these two things were come.
Yes, sir. I got.
Same. Now you think of B. Why this is, and we are not touched B. And this is take an exercise for how this B principled the way. Think of it. You understand, right? So this is what I am asking to develop the mathematics in a core way. Now I think if you don't you in your life never look back how the classification problem is defined in the core principle way. If you just revise and look at it, how simple mathematics is sitting inside and doing a mesmerizing things. Okay. So that my point of view, I cannot sit here and tell you break down all the models, what the mathematics going behind the things. So you have to spend a lot of time uh, by breaking down the mathematics into core principles and looking at them, how these formulated, how the definitions are ruled out. So I think classification definition you can give like this one. Okay, now here I'm stopping here at this point of time, but from here we can go. There is a Bayesian attraction also sitting there, Bayesian attraction, and a set of all points which are comes under one region, all those things. And this is not a unique solution. There are infinitely many solutions. If two points are can be classified, like any line can be possible, right? If pink points and blue points are there, we are not looking for. And what would be the best solution of it? And how do we find out that best solution out of these parameters, which is classifying? And how do we define what is best as well? One best, no, one model best decision is cannot be same for every other. Like it depends upon the situation or depends upon the problem. The we need to define the best. Okay, the finding it out the decision line. So these are all like the theory of advancement of mathematics. Again, a lot of mathematics sits there. Uh, yeah, I just stop here. Like you can take care and you can carry forward from this. Yeah, I think you worth it something today from the classification point of view. Yeah.
Yes, sir. Yes, sir. Yes, sir.
So this is what my convention or like uh, for you that don't look model, just don't look the models. Develop the models from the scratch. Okay. Yeah, we will meet uh,
On
Tuesday.
Tuesday, sir.
On
Yes, sir.
Tuesday.
Yes, sir.
Okay then.
Thank you,
Thank
sir.
you. Bye.